We are going to solve problem set number 2, question number 13, question number 14. So we have problem 14 and we have two vectors in cylindrical coordinate. A is rho sine phi A rho plus rho cosine phi A phi plus rho A z, and B is rho sine phi A phi plus rho cosine phi A phi and minus rho A z. And we need to find that if these two vectors are perpendicular. So A is perpendicular to B. This is we need to find. And how can we do it? It's taking a dot product. So if the dot product is 0, it means that the two vectors are parallel to each other and they are not perpendicular. So let us find the dot product of these two vectors. So I have A dot B is equal to I will dot each of them with each component of A with each component of B. So when I will dot A rho and A rho, the answer will be 1 because they are in the same direction. And if I dot A rho with A phi, the answer will be 0 because they are perpendicular. And if I also dot A rho with A z, the answer will be again 0. So this rule we have to keep in mind when we take the dot product. So it means that when I dot the A rho component with the A rho component of B, the answer will be rho square sine square phi. When I dot the rest of them, the answer will be 0. If I dot the phi component with the phi component, the answer will be rho square cosine square phi, and the rest of them will be 0, and the final dot product will be rho square. Now it is just very simple trigonometric relation. Sine square phi plus cos square phi is 1, so the answer will be rho square minus rho square is 0. So which means that the two vectors are perpendicular to each other at every single point. Okay, now let us look at problem 15, and we have two vectors again. A is equal to 3 A rho in cylindrical coordinate. So I have A is 3 A rho plus 2 A phi and A z, and B is equal to 5 A rho minus 8 A z. We need to find A plus B, which is very simple. I can just add the two. I don't need to do that. You can do it yourself. B part is A dot B, which is just equal to, as we did in the previous question, we just multiply the magnitudes of the same vectors, and if the two vectors are different, then the product will be 0. So A rho dot A rho is 1, so then 3 multiplied by 5 is 15, so it will be 15, and A phi dot A phi is already 0, and A z dot A z is minus 8, so the answer will be 7. And C part is A cross B. For that we have to write the vector, the determinant. So I have A rho, A phi, A z in the first row. In the second row I will have A, all the magnitudes of A, so 3, 2 and 1. In the third row I will have all the magnitudes of B, 0 and minus 8. So it will be A rho and I will cover this, and then it will be minus 16 minus 0 minus A phi A phi is this one, so I cover this, and then 3 multiplied by 8 minus 24 minus 5 minus 24 minus 5 and plus a z, that will be 0 minus 10, so that will be equal to minus 16 a rho, and then 29 minus 29 is 29 a phi and minus 10 a z. And this d part is I need to find the angle. So as we know that we can find the angle from either the dot product or the cross product. If the two vectors are like that and I need to find the dot product, and this angle is theta, so the dot product is equal to a magnitude multiplied by b magnitude multiplied by cosine theta. So cosine theta is just a dot b divided by the magnitude of a and magnitude of b. So it will be just a and then b. So a dot b is 7 and magnitude of a is 3 square plus 2 square plus 1 square, which is 9 plus 4, 13 plus 1. So this will be equal to just a dot b is 7 divided by a magnitude will be square root of 9 plus 4 plus 1, and that will be square root of 9 plus 4 13 plus 1 14, and multiply by square root of 25 plus 64, that will be equal to, let me just calculate it, I can use my calculator here. So it will be 25 plus 64, and that will be 89 square root. And I can do this and find the cosine inverse. So my theta, so from here, theta equal to cosine inverse of 7 divided by 14, that will be 7 divided by square root of 14 multiplied by 89, and that is so it is 1.37 radians, 7 radians, and I can convert it to degrees, and in degrees it will be 180 divided by pi. so it will be 78 degrees. So next problem is 16, and in this problem I am given a vector in cylindrical coordinate 3a rho plus rho cosine phi minus z square az, and I want to find a component of this vector along x-axis. So if this is x-axis and this is ax, I want to find this component here, component of g in the direction of ax, so let's call it gx. Now as you can see here that gx is the component of g along ax, so it will be the magnitude of this is simply gx g dot ax. That will be the magnitude. And that will be equal to and the direction of this is ax, so the gx vector will be the gx magnitude and the ax direction. So what I need to do is to just dot this with ax, the vector g, and this is in cylindrical, so it is my choice now to either change the g vector into Cartesian or take the dot product like that, because we know the relation of dot product between rho and x and rho and y and rho and z and so on. So I can find the first, if I can find the dot product, and then I can convert it into Cartesian to find the value at point Q. So I can just dot it like that, so it will be 3a rho dot ax plus rho cosine phi a phi dot ax minus z az dot ax. So this will be 0 because they are perpendicular. Now I need to find a rho dot ax. So this I can find by looking at the rules, the formula sheets, which is either in lecture 3 or lecture 4. You can go one of them. So I know I can write a rho in terms of x and y, so it will be a cosine phi ax plus sine phi ay, and a phi is equal to minus sine phi ax and cosine phi ay. So a rho dot ax will be equal to cosine phi ax dot ax, so that will be equal to cosine phi, and a rho dot a phi dot ax will be equal to minus sine phi. So I can come here and I can just multiply a rho by a rho dot ax, so that will be cosine phi, and plus rho cosine phi and minus sine phi, so that will be equal to 3 cosine phi 3 rho, sorry, there is a mistake here, it is 3 rho, this is 3 rho, so it will be 3 rho cosine phi minus rho cosine phi sine phi. So this is my gx magnitude. Now one more step is to convert this to Cartesian. So this is very easy conversion. This is x, so I can just write it 3x, and this is again x, so minus x, and this is sine phi, which is equal to, if we look at the rules, it is just equal to y divided by x square plus y square square root. So it will be y divided by x square plus y square square root. So now my gx vector will be just simply equal to this is the magnitude, and the direction is ax. So this is 3x minus xy divided by x square plus y square square root, and direction is ax. Now I need to evaluate this at points q equal to minus 3 minus 4 6. So I want to find this at q 3 minus 4 6, 3 minus 4 6. So this will be just, I put it here and I can just calculate it at x equal to 3 and y equal to minus 4. There is no z, so I don't need z for that. So that will be equal to, I can just use the calculator or MATLAB or any software you like to use. So the answer comes out to be, so gx is equal to 11.4 ax. Okay, now let us look at the problem number 18, or still 17. We have 2 points in cylindrical system. So we have P, 4, 30 and 0. This is problem 17. Actually I can call it the D part. 430, 0, and Q is 690 and 180 degrees. So this is in cylindrical system and we need to find the distance between them. So let us look at these 2 points, 4 outside and 30 degrees and 0. So it is around phi is 0, so it is, so we need to go 4 and then 30 degrees, and phi 0, so it is actually along so this is my y and this is my x. So it is on this plane. Basically this point is 30 degrees from here. This is 30 degrees. This point is around here on this plane. So this is on this plane here. And the next point is 690. So it will be on this plane, but it will be on this side, so it will be around here. So it's 90 degrees, but 180 from here, so 180 from here and 90 from here. So 90 from the z-axis and 180 from the x-axis. So this point will be here somewhere. So this is my P and this is my Q, and I need to find the distance between the two. So I need to find this distance. This is my PQ. So first of all I can convert them both into the Cartesian. So x equal to y equal to and z equal to x1, I call it x1, y1, z1, and x2, y2, z2. And from the formulas I know that this is r sine theta cosine phi, and the second, that y1 is r sine theta, r1 sine theta 1 sine phi 1, so this is x1 is 2, x1 is 2, y1 is 0 obviously because we are not going in the y direction, and also from the formula, and this is 3.46. Similarly x2 and y2 will be, so it's on this axis, so x should be, so if I calculate this, r cosine, r sine theta cosine phi, so y should be negative and x should be negative and y should be positive. So x is equal to -6, y is again 0 because it is on the x-axis, and z is also 0. So if I find the distance between them, or I can also call it d, that is equal to square root x2 minus x1 plus y2 minus y1 plus z2 minus z1, and that is equal to 2 plus 6, so minus 6 minus 2, 8 square plus 0 plus 3.46 square root, and this comes out to be equal to 0.7. Okay, in problem number 14, sorry 2.14, which is problem number 17 of the problem set number 2, I have to find the distance between 2 points in x coordinate, and then 2 points in y coordinate, 2 points in the Cartesian, 2 points in the cylindrical, and 2 points in the spherical. So I will start with the A part. For the Cartesian coordinates, I have x, so the 2 points are given by P 2 1 5 and Q, I will say Q 6 minus 1 2. So this is, I call it x1 y1 5 and x1 y1 z1. So I have x1 y1 z1 and x2 y2 z2. So the distance between the 2 points, this distance, this is P and Q. So this is in Cartesian system we call it PQ, or the distance, actually the magnitude is equal to square root of x2 minus x1 square plus y2 minus y1 square plus z2 minus z1 square, and the whole square root of this. So it is whole under the square root. So this is equal to, I just put these values there. So 6 minus 2 4 square plus minus 1 minus 1 2 square plus 2 minus 5 3 square square root, that will be 16 plus 4 20 plus 9 29 square root, and this comes out to be equal to 5.38. So this is my first point. Now the second question is, I have 2 points given in cylindrical system. Again I will use the same formula, but I need to convert the points into the Cartesian first. So I have 3 pi by 2 and minus 1, and Q is 5, 3 pi by 2 and 5. So I can just convert them into cylindrical. So x1 will be, let me just delete this here. So just delete this. So I need to convert. So x1 will be row 1, so I call this is my row 1, and this is my phi 1, and this is my z1. So let me just delete it once again. So this is just nothing. So this is my row 1, this is my phi 1, this is my z1, this is my row 2, this is my phi 2, and the third one is my z2. So row 1, so x1 is equal to row 1 cosine phi 1, y1 equal to row 1 sine phi 1, and z1 is equal to z1, and x2 is equal to row 2 cosine phi 2, y2 equal to row 2 sine phi 2, and z2 equal to z2. So these values, if I calculate them, they come out to be x1 equal to 0, y1 equal to 3, x2 equal to 0, and y2 equal to minus 5. So when I put this in the formula, d is equal to, again, x2 minus x1 square plus y2 minus y1 square plus z2 minus z1 square. So this comes out to be, if I put all these values, this comes out to be equal to 10. Alright. Similarly, the third one, I'll just save this one and I start a new one for the third. So that the C part is spherical, and the point is given by C part, which is P is given by 10 pi by 2, 3 pi by 4, and this is actually R1, as we know that theta 1 phi 1, and P and Q is 5 pi by 6 and 7 pi by 4, and this is again r2 theta 2 phi 2. So again the simple way to convert is we can use the rules. r1 sine theta 1 cosine phi 1, y1 is equal to r1 sine theta 1 sine phi 1, and z1 is r1 cosine theta 1, and these values, if we calculate them, they come out to be equal to so this is equal to minus 5 and 7.07, and similarly x2 equal to, if we put these values, comes out to be 1.76, y2 equal to minus 1.76, and z2 is equal to 4.33, and if we put the distance rule, x2 minus x1 square plus y2 minus y1 square plus z2 minus z1 square, this is equal to 9.95.